If you guys are looking for a way to pretty much emulate this kind of vision effect in 2D space for a game project or whatever, you don't really know how to do it, or more specifically, something that kind of looks more like this, then you come to the right place. I'm just going to show you basically just the basic theory behind how you would accomplish this like kind of line of sight effect, in kind of the most short and simple way as possible. Of course, like there are some micro optimizations you can do to also get rid of these artifacts, but for now I'm just going to focus on just basically teaching the fundamentals of it, right? So let's get started. For this tutorial I'm going to be doing everything in Raylib, but using C++. But you could obviously do this in any game engine you want, but I feel like just doing it kind of like on a lower level way, it would be just a lot easier to explain it. Unity has Raycast built into it. Unreal has its own version of Raycast, and it's probably honestly a lot easier to do than this. But even then, this implementation should only be like around 50 lines. So let's say we have a working Raylib loop. So I'm gonna just, you got like something like this going on. I'm gonna show you how to get started with that. So I guess first things first, you obviously want like a main, like a player character of some sort, right? So let's just like initialize a few variables for the player, I don't know, player location, and we're gonna have like player x equal to. I'm just gonna set it to the middle of the screen. Height divided by 2. And afterwards, right, and at least in Raylib, I don't know if you have your own player controller in Unity already done, it's probably, you don't really have to worry about this part, but let me just get that implemented right now. So let me speed this up for you. Alright, so we have just a little simple little thing for player movement, right? And then of course we need to draw our player, right? So let me just do that really quickly. So we're gonna do, thankfully Raylib makes this really easy. So we'll do like what? Player X, player Y, I don't know, I guess the size of the player. So you should have something like this now, right? Just like a simple little player controller, right? So now let's get into, I guess, just having like obstacles in the way. I guess like a really simple way to do that, at least with Raylib, right? In Unity you can have a game object with sprites or whatever, but we don't have that whole entity component system, so I'm just gonna make an example, at least like here from scratch, but which should be pretty simple to do. So I'll just make a wall struct with a start and end position and a simple constructor where we pass in of course where that start is and where that end is, right? I believe C++ syntax should look something like this. Right, so probably gonna make a new method here. Void, I'll just call it construct walls. And once I make a few set of walls, I'm just gonna quickly just speed this up. I don't think you guys want to see this, so just give me 1 sec. Alrighty, so now that we have that done, so now we just need to, just a simple way just to render, I guess render all the walls in place. So let us do that really quick, right? So yeah, I guess right here, I guess we'll do it probably after drawing the player. So draw walls. Okay. So now we should have, I don't know, something like this, some sort of scene, right? And in my case, I'm just storing this wall struct, or like this collection of walls inside of just a simple array list or a dynamic array. I'm just iterating through and just drawing them, right? So now that we have it in like a nice little convenient place here, just to make it a lot easier to access. So let me get quickly into the explanation of how we're going to get the Raycast vision to work. So the simplest way to do this through the CPU, at least like how I've done it, we're basically just going to take the player's position. We're going to fire out invisible raycasts that pretty much check for collisions like this if it hits a wall. And what we're going to do is what you notice too with these lines is that these are triangles, right? And computers love, you know, triangles. It's the easiest way for us to render things on screen, right? So you could simply construct, we're basically going to make a mesh and then basically draw this as white or whatever you want, or you could even do the opposite, right, in this case, and anything that's behind this will just be overcasted by black where you can't see it, and then anything that's in here you could see, right? So let's get started with that. Let's do that really quickly. Let's get started. So we need to draw lines around the player, correct? So, or maybe instead of lines, obviously we're going to refer to it as raycasts, just so it's a little bit more clear what we're doing here. So we're going to define a starting position for the light to occur at, because if we just grab the player position, it's going to kind of end up in the corner of the player's body, right? So we don't want that. So instead we're going to take the what you would call it, we're going to take the player's position, and I don't know, it's I added 50 to it, right? So I'll just do like 25. This is specific to my case, right? Because I'm doing everything in Raylib, but for those of you following along with me, you would have to do that, right? So it's everything's lined up correctly. And what we're gonna do, we're basically just always, for each frame, we're always just gonna loop in a circle, right, around the player. So I'll just do it for like every point, right? So go 360 degrees around the player. Iterate like that once, and then we will grab the current angle by doing I, and then thankfully we can calculate degrees to radians pretty easily with this Raylib built-in value. And then we'll grab the directional vector of where that angle is facing relative to the player by just doing, we need to do include CMath. We're gonna go down here, and then for the first for the x coordinate. In this case, it would be, I believe, sine, cosine of degrees. And then for the y value, it would be the cosine of degrees to get the correct value. So then after this, we need to grab, of course, like for each and every light beam, we need to find out where the light beam ends too. So we're going to do light end, and I'm just going to add two vectors. In Unity, you can literally just do like light end plus light start or whatever, or light start plus light end. But since I am in Raylib world, I'm not in an actual game engine, doing things a little bit sillier. So we're going to do light end, and we're going to set the, light end's equal to light start plus directional vector, right? But because directional vectors in, you know, radians kind of technically. It's only between 0 to 1, so it's a pretty small number, so I'm just going to multiply that by 1,000. This could be any, this is like an arbitrary number. But this is basically more or less the same as doing like in Unity, like light end equals to light start plus directional vector times 1,000. Right, this is more or less what I'm doing here, right? And then we want to grab the actual collision, point of collision, because we need to know when the line ends, right? And we can, and if there is a collision that we detect on a wall, then in that case we'll just set the endpoint to instead end where that point of collision is with the wall. So check collision lines. Beautiful little built-in function in Raylib. We'll do light start, light end, and then wall start, wall end. I believe just AABB collisions under the hood, nothing crazy. Then we'll do light end equals to collision. I believe that should be correct. We need to grab a ray, so we'll do that really quick. So Raylib has a built-in raycasting system, so I'm just going to make use of that. Light start x, light start y, and then ray direction equals to direction vector dot x, direction vector dot y. And then I've also created a new container. So you'll notice I have a collection called points, and pretty much what this does, it just keeps track of every single vertice of that light mesh that we're gonna construct that I told you guys about, right? So just make a dynamic array. We'll call this, in this case in C++, we'll call it vector2, call it points, and then obviously we don't want the mesh to stay the same the whole time, so every single frame we're going to call points dot clear, right? Keep that nice and clean. And down here we're going to need to draw that light mesh using those points, right? So we're going to loop through, this is where the points collection comes in handy here. For I is less than points size, plus plus. And then we're going to do, just draw a triangle. Draw a triangle, light start, points, and we're going to grab the current point that we're iterating over, right, as the first vertex, and we're going to go in a clockwise motion, because that's just how Raylib likes doing that. Obviously this varies depending on what your engine you're using. I believe Unity is the same way. And then we're going to draw the final triangle, which in this case, the one at the very end of the collection here. So sorry, this should be, yeah, this should be -1, and then this should be points dot back, and then this should be points at index 0, and then obviously, you know, whatever color you want. End drawing. Yeah. Also, yeah, because this is gonna hide the player as well, so we have to keep in mind of draw order here too, right? So, and then drawing will, of course, occur after we do our drawing. I believe that's everything. So first we're gonna handle player movement. Also, let's make it black. Let's give it a different color. So yeah, we're just handling player movement, drawing the walls. For each of the walls we made back here. We're drawing the walls. We draw raycasts around the player. We're not drawing them, but we're creating them. So I'll bring that to create raycasts. If I could spell create. Create raycasts around the player. And yeah, that's about it. So let's go see the results. Alrighty, and afterwards, before I show the example, I just wanted to point out that I made a few typos here and there, and so I didn't initialize this correctly. I think I had like 2 semicolons here or whatever. Make sure to replace that. Any silly compile errors, if you're literally copying my code one for one, just get rid of. I think I like said this was like point or whatever. There's no such thing as that. So, but yeah. Regardless, after all this, you should end up with a good place to start with a little scene like this. So you have a player that can move around. We have like a viewing radius that's determined by that 1000 value I talked about earlier. But yeah, hopefully this helped out a lot, guys, and then now you have a nice little basis for a game that you have now. Thank you so much for watching, and I'll catch you in the next video, hopefully. Maybe not, I don't know.